It is said that a car is moving at a velocity of 40 meter per second, decelerates to 25 meter per second in 30 seconds, and then it travels 400 meter at that velocity. How much longer does it take to travel the whole path than it would have taken if the car traveled at 40 meters per second the whole time? So basically the initial velocity is 40. If we draw a velocity time graph, it will look like this. 40 here, let's say this is 40, and then 25 here. It decelerates to 25 meter per second in 30 seconds. So that information we have. Then it travels at that velocity 25 meter per second. For the time is not given, but it travels another 400 meters. So this is 400 meter. This is what we know. So we have to find what is the time. I mean, what is the what is the amount of time longer time taken if when it travels like this, and what is the basically what is the time taken when it travels like this, and how much more it is taken if how much less it would have taken if it were traveling at 40 meter per second the whole time. So if it traveled like that, what would be the time? What would be the, I mean, how much time would be saved basically? So we can first find the deceleration value. So we can use this equation, v is equal to u minus at since deceleration. So that would be u minus v t, which will be 40 minus 25 over 30. So that would be 0.5 meter per second square. That is the deceleration. So with that information we can find what is this, how much is this distance. So that is s is equal to ut minus half. We don't know the time, so we can use another equation, which is this one. So v square is equal to u square minus 2as. With that we can find the distance. Basically, sorry, we know the time, we need to find the distance, sorry. So 2as is equal to u square minus v square. So s is u square minus v square over 2a, which will be 40 square minus 25 square over 2 times 0.1 is 1. So that's s is 975 meter. That's the distance traveled during these 30 seconds, 975 meter. So the total distance now we know. First we need to find what is the total time. So we also need to find how much time does this travel take, this 400 meter for at the velocity of 25. So we can just use that because that travels at a uniform velocity. So we can use this equation, s is equal to vt, which is the average velocity or uniform velocity basically. So we need to find the time. So 400 over 25, so that's 16 seconds. So this time, this much is 16 seconds. So the total time taken here for the travel that the car does, the way the car travels, that way it takes 30 seconds to decelerate plus 16, so that's 46 seconds it takes. Now the question is, if it had traveled at a velocity of 40 meter per second, that is if it didn't decelerate and traveled the whole path with that velocity, what is the time, what would be the time taken? And that would be again svt, and total s is now we know 975 plus 400, because that's the total velocity, and uniform velocity would be 40. So what would be the time there? So that would be 1375 divided by 40. So that is 34.375 seconds. So that's the time that would be required to travel at that velocity, which is, so with the travel with the way the car traveled, it took 46 seconds. So the amount less would be 34 point, what is 375 I guess. So that much. So if we just subtract this one, that will be 11.625 seconds. So that much time would be saved if the car didn't decelerate. If it had traveled at 40 meter per second, that would be the amount of time that would be saved. So that's 16.2 seconds. So as the question is said that how much longer does it take? So it takes 11.625 seconds longer to travel in this fashion. So 40 to 25, 40 meter per second to 25 meters per second, and so on. So yeah.